Yes, my students, are you well? Yes. Today we are going to take the topic under gravitation, Earth gravitational acceleration. Earth gravitational acceleration. Now see here. I'm going to write the definition of gravitational acceleration. The acceleration produced due to the gravitational force of Earth is called Earth gravitational acceleration. Earth gravitational acceleration. And it is denoted by small g. The acceleration produced due to the gravitational force of Earth is called Earth gravitational acceleration. As you know that the gravitational force applied on an object, it attracts the things towards the Earth, and due to that attraction there is change in the acceleration. I'm going right here. The calculation of value of G. Calculation of value of G on the surface of the Earth. See let an object of mass m is at the surface of Earth. Its distance from the center of Earth is r. Then according to Newton's according to Newton's law, according to Newton's universal law of gravitation, F is equal to G capital M small m upon R square, where m is the mass of Earth, where capital M is the mass of the Earth. Now see here, you know that F is equal to ma or is equal to mg. Why mg? This is the g means acceleration due to the gravitational force. Therefore, instead of a it is mg. Now substituting the value here means mg is equal to g capital M small m upon R square. Here m will cancel. Now therefore G is equal to capital G capital M upon R square, as the object is at the surface of Earth, R is equal to R, capital R, that is radius of Earth. Okay, radius of Earth. Now see, we can write here G is equal to capital G capital M upon, instead of small r, it is capital R square. Now see here, value of G is 6.67 10 raised to -11 Newton meter square per kg square. Similarly, mass of the Earth is equal to 6 into 10 raised to 24 kg, and radius of Earth is 6.4 10 raised to 6 meter. Substituting this value here, G is equal to G is equal to 6.67 10 raised to -11. M is equal to 6 into 10 raised to 24 upon here 6.4 into 10 raised to 6 square. After solving this, we will get the value 9.77 meter per second square. It can be written as G is equal to 9.8 Newton per second square. Okay. Therefore, G is equal to 9.8 is considered as the constant acceleration due to gravity. Okay, its value is constant on the surface of the earth. Afterward, there is given the variation in the value of G. The variation in value of G. Okay. Here, if you will see that the shape of the earth is not exactly spherical. Shape of the earth is not exactly spherical. It's, see here, the radius of the earth at the equator is larger and radius of earth at the pole is smallest. This is due to the rotation of the earth. Earth bulges at the equator and flattens at the poles. Okay, this is the reason. Now I am going to write here first change along the surface of earth. The reason behind it is that first here the shape of earth is not exactly spherical. Okay. Why it's not spherical? Due to rotation, the earth bulges at the equator, and you can see here the earth bulges at the equator and slight flatter at the poles. Okay. Then what happened? Due to this, the radius at the equator is larger and at the pole it is smallest. Thus, the radius of earth at the equator is largest and smallest at see here, in the equation, if, see, equation is this, G is equal to capital G M upon R square. Now see here, as the value of R will increase, the value of G will decrease. Therefore, the value of G is highest at the pole. How much that? G is equal to 9.832 meter per second square, and lowest at equator, that is G is equal to 9.78 meter per second square. Okay, understood why it's so. Now the next here, that is change with height. Change with height. Now see here, I am going to write here the formula G is equal to G upon. Now see, as the height will increase, I am going to draw, suppose this is the earth here. Now suppose this is your earth, okay? This is your earth, and its radius is here R. Here its radius is R. If we will go upward on the above the earth's surface, then what will happen? This radius will increase, value of R will increase, and as the value of R will increase, the value of G will decrease if the object is over here, okay? Then the value of R will increase. So that I am going to write here, you write like this, as we go above the Earth's surface, the value of R in equation, which equation? G is equal to capital G M upon R square. The value of R in equation increases and thus the value of G decreases as per formula. Understood? As per formula, the value of R will increase, the value of G will decrease because they are inversely proportional. Now, the third factor, that is change with depth. Change with depth. Now see, I'm going to rub it. Now suppose if the object is somewhat inside the earth, now see here, suppose the object is, now if the object somewhere here, then what will happen? This R, value of R will decrease. Okay? As the value of R will decrease, the value of G should increase. Understood? Here, I am writing here. As we go in depth of R, the value of R in the equation, which equation? G is equal to G capital M R square. The value of R in the equation decreases. Thus, the value of G should increase as per formula. But this not happened. Why it's not happened? See here, I am going to explain you what happened when the object will be here. Then only this part of the, means part of the earth which is inside this, will affect the or will contribute in the gravitational force of the earth. The remaining part of the earth will not contribute in the gravitational force of the earth. It means that the mass, value of mass will also decrease. Value of mass means if the value of M will decrease, then the value of G will decrease. Understood? Okay? that I am going to write here. See here, but however, the part of earth which contribute towards the gravitational force felt by object also decreases. It means the value of m in the formula decreases. Thus, due to the effect of both R and M, the value of G decreases in the depth of Earth. Understood? As I told you, again I am telling you, what happened? The remaining part of the Earth here, the mass of Earth is changing or mass of Earth is decreasing. As I told you, the outer part of this is not contributing in the gravitational force of Earth. Therefore, this value of G is decreasing inside